Hi, teacher Jerry here. Today, the topic that we cover is on periodic table, right? And of course, the big picture in chemistry is that we are always, most of the time, we are categorizing, right? If we have been learning chemistry and noticing it, is we mainly has been categorizing in trying to understand or trying to explain what we are observing. So in periodic table, we categorize them by group. Okay, this will be in the three parts video. The third part, the part three of this video will be more for the pure chem. So first, let's go through the combined chem part or for whether combined and or pure chem they will still learn this. So let's go to the periodic table, the keywords. Right. So we know that all elements are actually arranged by the periodic table, the atomic number, sorry. Right. So this is one of the keywords, the atomic number. Okay, it means the number of protons. Right. So let's recap. Right. We learn in chemistry, basically there are two number in a periodic table with the symbol to represent the element. So we are looking at the atomic number. Okay, remember chemistry is about electrons. Okay, protons, neutrons, we don't really study much about them. They are covered under isotopes or when we do calculation, right? We need the mass number. So, but there's no proton number. I mean, there's no electron number in a periodic table. They only atomic number, but we understand that 11 in an element, proton equal to the electrons. Right. More important thing is the electronic structure. So can you see now the group, right, is the number of valence electron. That means if I look at sodium, I look at the electronic structure, I know that I have one valence electrons. Right, valence means in the outermost shells, and this belongs to group one. Right, period. Okay, this is the vertical. Right, group is the vertical. Then period is the horizontal. Right, it's about the number of electron shells. So you can see one, two, three. We put the arrange the electrons, we put the electrons in the electron shells. So in this case, sodium will be in the third period. So it's like reading a graph. You got the x-axis, you got the y-axis. Just like now the x and y-axis represent different things. So if you look at group one and period three, third period, the third row, you will find sodium. So that's what we meant by arranged by atomic number, the proton number. All right. So when you look at a group, you can see that, even when you group 12 or you have a group 13, 14, 15, the last digit tells you the number of valence electrons. All right. So similar valence electron means similar chemical properties because by now we already mentioned that it's linked to the chemical reactions. And of course, all right, they need to be stable. We learn in bonding. All right. So they were one of the way to be stable is by losing or gaining electrons. That depends on the valence electron. That's why they form same charge. All right. And because they got same charge, they will have same or similar formula. Then when we talk about period, means we talk about electron shells. Okay, then see left to right the trend, matter to non-matter. So we know that matter technically likes to lose, easier to lose electron to be stable. Okay, then non-matter means the opposite of matter. So it will be gain. See, so we don't really to memorize everything. We can just look at the relationship and it help us to relate and easier to recall. Okay, so definitely the ability to lose electron decrease because it's non-matter, right? Left to right, so it's harder to lose electrons. Or we can even change and say that the ability to gain electrons increase, right? Because you're forming non-matter. Okay, and then we also learn this in the acid bases. All right, basically the basic oxide is the metal oxides. All right, okay, and the non-metal oxides are the acidic. Right, if you forget, look at the formula of acid, hydrochloric, sulfuric, nitrate. All the formulas in this acid contains non-metal. Okay? And amphoteric, you realize that actually between the metal and non-metal boundary, if you find the amphoteric like aluminium, zinc, like they are very close to the metal non-metal boundary. That's why they can behave like a metal, it means behave like a basic oxide, or behave like a non-metal means acidic oxide. That's why they can react with both acid alkaline. Right, that's the big picture. So you can see that in this simple topic, we have recovered some revision topics. We revised some of the concepts that we learned earlier in atomic structure, in acid base, All right. So, and you, as you can see, all these are linked up. Then you are actually learning. Okay, when you see a relationship, then you don't need to memorize so much, and you don't need to say, I want to wait to get myself a time to study. Right? You can always choose to learn now, and now maybe when learning this topic, it gives you another way of relating back to what previous topic that you have learned, which you may find difficult, but now you can see maybe even be easier. Right? That is one way of how we learn. Okay, so let's check on part two for the for this part of the video or for this part of the topic periodic table. All right. Thank you.